Section 3.2 is about comparing and ordering fractions and decimals. And there's two ways to do this. The first way is to use a number line and use benchmarks. Benchmarks are like numbers that you do know, like a half, or 3/4, or 1/4. The second way is to use place values. And I'm going to do that showing, first of all, the number line method. All right, here's what we have. It says arrange the fractions and decimals given below in order from least to greatest. So whatever's the least should go first, and whatever's the greatest should go way over here. So I start by just drawing a number line. Now I can look at these numbers and I can see that I've got 1.5, I've got something that's going to be less than 1, something that's going to be less than 1, something that's going to be less than 1, and something that's going to be less than 1. So when I draw my number line, I'll go right in the half there, and I'll go right there and right there. Now you always start with 0, and I know I'm going to need to go a little more than 1.5, so I'm going to need to go probably to 2. 2 will cover it. Now what's in between 0 and 2? I can put down 1. Now I can go ahead and plot my first one. If I look at 1.5, well, decimal 5 is right in the middle of 1 and 2. 1.5 is right here. So I can take 1.5 and I'm going to write him right here, because 0.5 is half, so 1.5. I'm going to take the next one, 5/6. Well, we know that 5/6, if I take it right here like this, okay, I know that 5/6 is not quite 1. Okay, it's not quite 1 whole. So I could break this number line into 6 pieces. Okay, or I know that 5/6 is going to be roughly about, let me see, right here. So it's close to 1, but not quite. So 5/6 will probably go about there. So I can take him, put him there just for now, and we'll see in a moment there how I can prove that it's there. The next one is 2/3, and if I take 2/3 and I break my number line between 0 and 1 into 3 equal pieces. So there's 1, 2, 3, well, this is 3/3. And now I'm going to move it 1/3, 2/3, and there's my 2/3 right there. And I should put a dot right here for 5/6. And we'll see how 5/6 will be a little bit more than 2/3 now in a second. Now the next one I've got is 3/4. Well, if I take my number line and I break it into 4 equal pieces, well, let's go right in the middle between a half. There's one right in the middle there. And I'm going to go half of this will be about right, let me see, half of this will be about right there. Okay. And then half of the other side will be about right there. Now I'm going to go ahead and mark out 5/6. Oh, sorry, 2/3 is done, 3/4. So 1/4, 2/4, 3/4 is right there. So I can take my 3/4 and I can write it right there, like that. The last one to do is 0.12. And if I look at 0.12, I can write that over as 12/100 if I wish, okay, or 1.2 out of 10. So if I break this up into 10 little pieces, it's going to get very tiny very quickly, and it'll end up being about 1.2 out of 10 will end up being about right there. There we go. So 0.12 is right there. Now I've got them in order from least to greatest. So this guy's first, this guy's next, then this guy, then this guy, and then finally this 1.5 there. Now, That's a way to do it. Now this one was a little bit harder on a number line just because it was a little bit hard to cut them into pieces in that properly. I could do this one real easy with a number line because they're all out of the same pieces. Okay? But the other way to do this one, we could have written this as, let's take the same ones. So I'll take this guy, I'll move him down. I'm going to do the exact same problem, but this time I'm going to change them. So let's take 1.5. That's pretty easy. But I could take 5/6 right here, and I could write that as a decimal. I could go 5 divided by 6, but we're not going to do that right now. Oh, sorry, 5 divided by 6. We're not going to do that there right now. I could take this one here 2/3, and I could change that one to a decimal. So I could go 2 divided by 3, okay, and I could write that as a decimal. But the easier way to do it is to just simply come up with common denominators or make the bottoms the same. Okay? So let's look at it. 1.5, well, right away we know that's going to end up bigger because there's nothing there that's even close to 1.5. So this guy is going to be your greatest. You know that right away. Now what about 5/6? Can we compare that to 2/3? And can we compare that to 3/4? Well, you know you can't compare the bottoms because they're not the same. But can we make all of these the same somehow? Well, if you double this, wouldn't it become 6? Let's try it. Let's times this by 2 and times this by 2. What will we make 2/3 into out of 6 then? 2/3 is 6, 2 2s is 4. Aha, now it's easy to compare these two, isn't it? The 5/6 is bigger. But what about this guy here? Okay, we can't change him to anything here. This one won't change to 6ths. But what do 3, 6, and 4 all have in common? Well, if you count by 6s, 6, 12, 18. Okay? And if you count by 3s, 3, 6, 9, 12. And if you count by 4s, 4, 8, 12. Aha, 12 is the same for all of them. So I could change them all to out of 12. So how can I make them all out of 12? Well, what would I have to multiply the tops and the bottoms by? What would I have to multiply this by to make it 12? I'd have to double it. What would I have to multiply 3 by to make 12? I'd have to multiply it by 4. What would I have to multiply 4 by to make it 12? I'd have to multiply it by 3. So 2 times 5 is 10, 2 times 4 is 8, 3 times 3 is 9. Now they're real easy to compare. Which one's the biggest? This one right here, 10, 12. So 5/6 is the bigger. So I'll move these up here so they're right there like that. Now out of these two, which one's bigger? 8/12 and 9/12. Yeah, this one was definitely bigger. So that leaves us with 2/3 next. And we know that 0.12 is going to be 12 out of 100. And we can easily compare that to this one. It's going to be like 1.2 out of 10. You know right away that's not even close to half. 0.12 is not even close to half, and all of these are more than a half. So 0.12 should come first. So there's two methods to do it. You can plot it on a number line, break up your number line and plot it in, or you can write equivalent fractions for each one and just compare them that way. This one here, they're all the same denominators, so it'd be real easy just to simply draw a number line. Okay, and we know we're going to be going up for one whole, so I'll put one whole there, start off at 0. So I'm going to need a little bit more than 1, so 1 to 2 should do it. And what is each one going to be broken up into? 6 pieces. So I'm going to take each whole and break it up into 6 pieces. So there and there is in the middle, 2, 3. So 1, 2, 3, 4, 5, 6. 1. Oh, I should have done in the middle first. There you go. And then that's 1, 2, 3, 4, 5, 6. So the first one is 1/6. So I'll plot 1/6 right here. 8/6. Well, here's 1, 2, 3, 4, 5, 6, 7, 8/6 is right there. 8/6 is also known as 1 and then 2/6. What about 3/6? Well, that's halfway. 1, 2, 3, 6 is right there. 1 and 1/6. Well, here's one whole, and then there's one more sixth. So there's 1 and 1/6 right there. And the last one, 6/6. So you can count starting at 0 and go 1, 2, 3, 4, 5, 6. But you knew that was going to be equal to one whole anyway, because 6 out of 6 is the whole thing. It's one whole. So now all you have to do is rewrite these numbers, drag them on down, and put them in order on the number line. You could always write them out if you wish afterwards. And there they are. Oops, we don't need that one, do we? Now, which one of these numbers has been placed